sometimes you're going to have x on both sides of the equation. So what happens when you have x's on both sides, like this example here where 10x equals 2x minus 16, your variables have to be on one side of the equation to solve for it. So the goal would be to get letters on one side and numbers on the other side of the equal sign. So when you start with this one here, I see that I have more x's on my left side. So what I'm going to do is subtract off that 2x. Now in all reality you could go either way, but I'm going to subtract the 2x to both sides. 10x minus 2x is just 8x. When I subtract it from this side, it goes away because 2x minus 2x is 0. So I get 8x equals negative 16. At that point, it's just dividing by 8. And once you do that, you get x equals negative 2. As always, you can check your answer, and you simply check it by plugging it back into that original 10x plus or equals 2x minus 16. So when I do that, I plug it in over here and I get negative 20. Does it equal negative 4 minus 16? When you add together negative 4 and negative 16, sure enough, you get your negative 20 equals negative 20. Now, just because we know we need to get x's on one side, numbers on the other, doesn't mean we just totally get to disregard things like distribution. So when I have this over here, the very first thing I'm going to have to do is distribute. I've got to get that 5 into the parentheses and get 3x equals 5x plus 10. So when we do that, I now can subtract the 5x from both sides, and I get 3x minus 5x. So that's negative 2x. Could you have subtracted 3 and then subtracted 10? Yes, you could. But what we're going to do here is we're going to move the x's to the left side and keep my numbers on the right. When we do that here, I get negative 2x equals 10. I'm going to divide both sides by negative 2, so x is going to equal negative 5. You check your work always by plugging it back in, and I get 3 times negative 5. Does that equal 5 times negative 5 plus 2? Negative 15 equals 5 times negative 3. Sure enough, negative 15 equals negative 15. So here, what is the first step you would take to solve each equation? So truly what we're looking for here is I'm going to subtract 3x from both sides. It's not asking you to solve it. It's just asking you to figure out what you would do. So for this one, what would you do? Well, I would add 4x to both sides. And here, I would subtract 15x. And I know this is already negative and it's just going to make it more negative, but I'm going to keep my number over here and I am going to get all of my letters onto the right side. So I'm going to subtract 15x from both sides. Okay. All right, so solve each equation. This is where we're actually going to have to start doing this work. So I'm going to distribute the 5x, and I get 4x plus 2, because I didn't change this side, equals 5x plus 50. I want my x's over here, and I want my numbers over here. So I'm going to subtract 5x from both sides. I'm also going to subtract 2 from both sides. So what I get is negative x equals, and 50 minus 2 is 48. Well, if negative x equals positive 48, then positive x equals negative 48. And you can plug that into your calculator. So I'm going to say, does 4 times negative 48, because that's a big number, plus 2. So let's see, what does that equal? That equals a negative 190. So now I'm going to go over here and I'm going to say 5 times negative 48 plus 10, and I'm going to close that parentheses, so it looks just like it, except I'm going to have a negative 48 in for x. Looks just like that, and I'm going to hit equal, and they both equaled the same number, so I know they equal each other, so I have checked the work, and I'm good to go there. So what I'm going to do here, I'm going to combine my like terms first. So this is going to be y minus 7 equals 4y minus 13. I have more y's on my right side, so instead of moving this direction, I'm going to get rid of this y and move it over here. So I'm going to subtract y from both sides. If my letters are going over here, then my numbers need to go to my left side. So to get rid of this negative 13, I'm going to add 13 to both sides. I'm going to underline, and what I have here is negative 7 plus 13, and that's just going to equal 6. and then I'm going to have 4y minus y is 3y. Divide both sides by 3, and I get 2 equals y. So to plug in, I get negative 10 plus 2 plus 3 equals 4 times 2 minus 13. So you can use your calculator again for this. You don't have to do all this work. So negative 10 plus 2 plus 3, and that equals negative 5. Okay, so then I'm going to say 4 times 2 minus 13. Again, that's the same, I made it look the exact same way as it is written here. And I'm going to hit enter, and sure enough, negative 5. So it checks out as well. I'm going to distribute 3t plus 21 plus 2 equals 6t. And I'm going to change the order here. Plus 2t minus 2. See, I'm off the video a little bit, so there we go. So now I'm going to combine my like terms, and I'm going to get 3t plus 23. I combine 21 plus 2 equals, I'm going to 6t plus 2t is 8t minus 2. So I have more letters on my right side, so I'm going to subtract the 3t from both sides. I'm going to add the 2, and I get 25 equals 5t. Divide both sides by 5, and 5 equals t. So to go back and check the work, I'm going to go all the way back to the original. So I'm going to say 3 times 5 plus 7 plus 2 equals 6 times 5 minus 2 plus 2 times 5. I'm going to plug both sides of this into my calculator exactly like I saw it. So I'm going to say 3 times 5 plus 7, and that equals, plus 2, and that equals 38, equals 6 times 5 minus 2 plus 2 times 5, and that equals 38. And that's it. All right, we got solving equations with variables on both sides. This is just a continuation. All right, so this talks about sometimes you have infinitely many solutions. So how does this happen when you have infinitely many solutions or when you have no solution? Well, what happens when you start moving everything around, you end up with the exact same look on both sides. So here I've combined my like terms. I get negative 3x plus 9 equals negative 3x plus 9. Well, when I start getting rid of my variables, I end up with 9 equals 9. Well, 9 always equals 9. Always, always, always. So because it's always true, every number I put in for x, it doesn't matter whether I put a 1 in here, whether I put a 20 in here, every number is going to work and make it true. So it's the set of all real numbers. Likewise, sometimes you end up with, I get 5x plus 6 equals 5x minus 10. Well, when I get rid of the 5x, I get 6 equals negative 10. 6 is never going to equal negative 10. It's a false statement. Because I end up with a false statement, whether it's 0 equals 10 or 3 equals 6, whenever you end up with these two numbers that don't equal each other, but it says they're supposed to, that means there's no solution. That the system, the two equations don't make any sense together. So if we're to go here to solve each equation, if I subtracted x from both sides, I end up with 2 equals 4. Well, in that case, there's not going to be any solution, because 2 is never going to equal 4. Well, if I look here, negative 2x and positive 2x, and then I get 4 and 8. So I'm going to add 2x to both sides, and I'm going to subtract this 4. So I get 4 equals 4x. Well, x is just going to equal 1. And what I can do is I can plug in 1 to both sides, and I get negative 2 times 1 plus 8 equals 2 times 1 plus 4. Well, negative 2 times 1 is negative 2 plus 8 is going to be 6. And then 2 plus 4 equals 6. So this is a true statement. The only solution is x equals 1. So if I look here, I get 5 plus 3g equals 3g plus 5. Well, order doesn't matter, so I'm just going to rearrange this. 3g plus 5 equals 3g plus 5. Well, that's always going to be true. They're identical. It's a mirror image of each other. So because it's always going to be true, we're going to have infinitely many solutions. Well, let's take a look at this one over here. I got 5x, I'm going to rearrange them, 5x minus 4x minus 1 equals x plus 7. When I actually combine these like terms, I get x minus 1 equals x plus 7. Well, there's no number in the world that if I subtract 1 from it, it's going to equal the exact same thing as if I add 7 to it. This is going to be no solution. This cannot equal that. All right, after I distribute, I get 2f plus 6 plus 4f equals 6 plus 6f. Well, if I combine like terms, I get 6 plus 6f equals 6 plus 6f. They're identical. Because they're identical, anything I plug in on this side and this side, it's going to make it the exact same thing. So this is going to be your infinitely many solutions. And last but not least, I'm going to combine my like terms over here. So I'm going to say 3x minus 2x is just x plus 7 equals 4x plus 10. I'm going to subtract x from both sides. So if my letters are going over here, my numbers will end up over here. So I need to subtract 10 from both sides. The x's go away. I get negative 3 equals, and this is going to be 3x. And this is going to go away. Divide both sides by 3. And I get negative 1 equals x. We always, always, always need to check our work. So 3 times negative 1 plus 7 minus 2 times negative 1 should equal 4 times negative 1 plus 10. So again, I'm going to go to my calculator. I'm going to make it look identical on both sides. So I'm going to say 3 times negative 1 plus 7 minus 2 times negative 1. This looks identical to what I have here. So that equals 6. Okay, let's see what I get when I plug it in on this side. So 4 times negative 1 plus 10, and it equals 6. So 6 does in fact equal 6. So that checks out.